Hello, everyone, and thank you for joining today's session. My name is Reese, and I'll be your moderator and host for today's session. We are going to get started in a few minutes. We're just waiting so everyone has a chance to join. In the meanwhile, though, there is a little bit of setup. If you'd like to code along with us live today, there is a link to the session resources in the video description on YouTube. I'll also be posting the link for everyone watching on LinkedIn very shortly. I'd recommend watching on YouTube, though. The LinkedIn player experience is not so good. If you'd like to code along with us today, there was some setup info shared with you via email. But yeah, it's in the video description, and I'll be posting a link to it very shortly. However, we are going to be running through a couple of slides at the beginning. So if you haven't done the setup instructions just yet, if you haven't completed them, there will be some time for you to do that at the beginning. So I'd recommend having a look at the resources document now, which is in the video description and in the chat. I'll post it again for everyone very shortly. But yeah, have a look at that now if you'd like to code along with us today. However, if you want to just watch along, we are going to be recording this session, and we'll be sending out the recording to everyone that's registered in the next couple of days. So make sure you register for the session. You can scan the QR code on screen now, and you can also head over to datacamp.com/webinars, where you'll find this session as well as all of our future sessions as well. If you have any questions at any point throughout the session, let us know in the chat. We're going to be answering your questions for the final 10 minutes of the session. So yeah, make sure you stick around for that. And for anyone that's just joined, welcome. My name is Reese, and I'll be your moderator and host for today's session. We're going to get started very shortly. We're just waiting for the last few people to join, and then we will get started. If you haven't done so already, check out the resources document that is in the video description on YouTube. For anyone watching on LinkedIn, I'll be posting the link to it very shortly. And then, yeah, that's you all set up. We are going to be sharing the slides that we're covering at the beginning of the session. We're going to be sharing those with the recording. So make sure you register for the session, and then we can send you the recording and all of the complementary documents. Brilliant. I think that's everything. So now I will kick us off. Let's go. So hello, everyone. Let me hide the music, and then we will get started. As you may have noticed, it's just me today. There's no Richie, so we'll have to struggle through this and not have his beautiful voice getting us going. But without further ado, welcome to the session. Hello, everyone. So I'm Reese. I'm usually the backend moderator for these sessions. You may know me. You may not know me, but I'm not Richie. But you're all data scamps and data champs, regardless. One of the biggest keys to success with AI is making sure that it has the right information to solve the problem. When you're a human interacting with a chatbot, it's fairly straightforward. You type what the AI needs in a prompt. But for AI applications and AI agents, some automation is needed, and then you end up with more sophisticated solutions like RAG, or retrieval-augmented generation, and context graphs, the latter of which are the focus for today. Our guest today is Nyah Macklin. I will just bring you on now, Nyah. Welcome.
Hey, everyone. Thank you so much.
Pleasure to have you. So Nyah is a senior developer advocate for AI at graph database company Neo4j. Nyah is a software engineer and developer relations expert. Nyah helps developers use Neo4j for AI engineering, and Nyah is also the CTO and founder of Afros in the AI technical community. Previously, Nyah was lead developer advocate at Couchbase and the chief of staff for the Commonwealth of Massachusetts. So yeah, without further ado, over to you, Nyah.
Awesome. Well, thanks so much, everyone, for coming. Excited to join you all today. And we are going to talk about effective context engineering techniques for artificial intelligence. So we're going to dive a little bit into the entire Gen AI landscape, how to build out context, what are some different techniques that we can use to build out context as well. And then we're going to get into a hands-on demo. So just a key point here for our hands-on demo, we were going to be using GitHub code Codespaces, but it seems like GitHub Codespaces is down this morning. An outage. We love an outage. But so instead, we're actually going to be developing locally today. So if you haven't already, because you were depending on just using our enclosed environment, I'd love for you to install Python if you have not already. And you'll also need to install a couple different dependencies as well. I'll give you all the information here. But Python's the main thing, as well as an IDE that we'll be working in. Now, if we're going to be talking a little bit before we get to the hands-on demo. So if you're not able to install those things prior to us actually live coding today, then that's perfectly fine. What I want you to do is just sit back, enjoy the ride. And then after, I have the link where that you can do all of this work yourself, right? You can do all of this all within the enclosed environment. We're going to be using what's called Graph Academy today. And Graph Academy is Neo4j's online learning platform where you can learn about Gen AI, graph, context graph, all the newest concepts, what's happening within artificial intelligence. And hopefully GitHub Codespaces will actually be up for you. I just got a ping from my colleague that said it's been a little bit unstable for them too. So let's just get started. Again, if you don't have time or you can't coordinate getting Python installed plus an IDE, then just sit back, relax, and I'll provide all of the resources for you to do this completely hands-on right after this call. So let's get started with what we're going to be talking about today. So, okay, just a quick introduction to myself. My name is Nyah Macklin. I'm a senior software engineer and a senior developer advocate here at Neo4j. And my research focuses a lot on graph theory, graph algorithms, and trying to help people understand context engineering as this black box phenomenon. And we're trying to break open that black box in order to decipher, trace, and explain how artificial intelligence systems work. So we don't have to go all the way into my background, but if you want to find me on LinkedIn to chat a little bit later, there is a QR code there for my LinkedIn, and I'll have it at the end of this talk as well. So let's start off with a question. What happens when dozens of AI agents actually have to work together, right? So we would hope that it's an actually harmonious experience, right? Where it's like a sheet of music of agents just dancing together, right? But in reality, if simply unleash this swarm of different agents, right, you then start to find out that they're trying to work together to solve a particular problem, but maybe some are coordinating on a task and then others just really need to stay out of each other's way. So there's a large risk of something that would happen and to look like this. Okay, chaos. It's like planes that are on their own flight paths and without air traffic control, right? Each plane can fly, but it's flying without coordination and without guidance. And so really you have chaos in the skies. So the same actually goes for agents. So when they work in swarms without structure and orchestration, it actually becomes madness. And so we often find that this statistic rings true for a lot of agent development. So when teams are trying to put agents into production, 95% of AI projects or AI pilot projects are failing, according to this 2025 study that was done by MIT. And I have the QR code here so that you can read the study yourself, right? Don't take my word for it. Actually read the white paper. But when that project fails, that's a lot of time and a lot of money that has already been invested into that work. So let's freeze time. Why are our AI agents failing, right? AI agents are failing often because they don't have the right context. Okay, this is the key part. They're flying around in swarms without air traffic control, which then, says, okay, one plane should land right now. This other plane is having an emergency. So we need this gate open with medical staff ready, right? All these things, we need that air traffic control. We need the overall context in order to understand what's happening. That's the missing ingredient. So we get into context engineering. So context engineering, for those who are not experts and can't just define it themselves, and I wish we were live in person right now because I would call on you to say, okay, how do you define context engineering? But how I define it is that it's a discipline that systematically provides models with the right information, with the right tools, and with the right instructions that an AI agent will need in the correct format at the correct time. Okay. to specifically accomplish a task. So it's unlike prompt engineering, where you're just trying to say the most cleverly worded thing to the LLM to get it to do what you want it to do. Context engineering centers around building dynamic systems, right, that assemble complete and structured context for each LLM implication. So this is a shift in focus from using your cleverly worded prompts to actually doing cohesive context design, right? So that's why context engineering has become like a critical skill for AI engineers these days. And there's lots of ways to do context as well, to do context engineering. I have a few here. I'm not going to dive deep into them today because I want us to actually get into the hands-on tutorial. But context engineering has all of these different facets. So we have RAG plus hybrid search, which in a previous life, I was a teacher. So I always like to have little images to help those who learn more visually, plus those who learn with more auditory help. So I have RAG plus hybrid search, which I represent as this really hilarious meme. How do you do, fellow kids? Right? It's the OG way of doing context engineering, right? It's some I would call naive RAG, for example. It's RAG vector search, and then you can include hybrid search in order to make it more complex. And in order to make it hallucinate less as well. So I'm not going to get into each of these. We can do a whole talk on each of these, but I just wanted to share a little bit of the various ways that you can do context engineering. Memory management is the second way, for example, and I have that represented as Dory. But all in all, what you have to remember about memory management is that you are trying to get your agent to decide what it's going to forget. So Dory is a very forgetful fish in the movie Finding Nemo. Anything you tell her, she'll forget instantly, right? But with your AI agents, with memory management, you are deciding, okay, like what is okay to forget? Should I forget the older stuff, right? Should I forget the newer stuff? And you'll see that usually with your models, they'll opt for forgetting older stuff to promote the newer context that you're providing. But that's another aspect of context engineering. And then we have tools and function calling, right? I have this represented as MacGyver. For those of us who are older, we remember MacGyver would always have any tool. He was the guy with the plan, right? He would always have a tool to get a job done. He couldn't do it himself, but he would always have these tools. So I have that represented as tools and function calling because you can use your agent instead of having your agent do a lot of that heavy lifting. You can actually have your agent just call a tool so that your agent can focus on the things that it's actually good at, which is reasoning, right? And then up above that, I have structuring and ordering context. We all know, and Anthropic has lots of guidelines on this, but we all know that when we have a context window, you want to make sure that you are putting the most important context at the top so that your agent can remember that context, right? Don't put it at the bottom of that prompt, right? It's just going to forget it. You need to put it at the top. So that structuring and ordering of the context is actually really important. And then lastly, what we're going to get into today and building out knowledge graphs as well is knowledge graph augmented context, which actually uses knowledge graphs as the key point, as the key center for augmenting your context or making your context much more, making your context and your agents much more trustworthy. So we're going to dive into that quickly. So for those who are not familiar with knowledge graphs, I just wanted to give you a representation of what they look like. A knowledge graph represents data in ways that's both human readable and machine readable. So here we have a human readable view of an apple, or a human view of an apple, right? Red apple, pretty simple. But usually with naive RAG or vector-based RAG, you'll have this vector-based representation of an apple, right? Whole bunch of numbers, whole bunch of like really mess, right? Because you're like, I have not memorized what the view of an apple is, or the vector view of an apple is. I don't know if you have. So here on the other side of that, we have a knowledge graph view of an apple. So we have vector-based view and then a knowledge graph view. We have, for the knowledge graph view, you actually can see these what we call nodes, which are the circles, and then edges, which is the relationships. how things are related to each other in a human readable and machine readable way. So we see that an apple has a body which is round. We're not talking about the company apple, we're talking about the fruit apple. It's a fruit, it's sweet, it has a white inner most of the time, it has a stem, all this information. So you can see when you represent data in a knowledge graph, you can see that it's much more understandable for humans and also for machines. And just quickly, this is another representation of how people mostly use data themselves now. Most people are using data or storing their data in tables and rows. And so it's pretty hard to see how things are related to each other or how things have relationships to each other. And I've drawn these lines here to just try and show you what those relationships could look like. However, that's not normal within a SQL table. You'd have to do complex joins in order to show and showcase the relationships. But then when you're doing those complex joins, a trade-off is that it slows down your application, right? It builds a lot of bulk into your application. And so if you take that same data and showcase it as a knowledge graph within your data structure, you can actually, as a human, see how things are very well connected, right? You don't have to do all these complex joins and trying to figure out, okay, like how does that thing actually relate to each other? But actually everything is more intuitive. Everything is much more clear. So in other words, if you're using a knowledge graph when building out agents, a knowledge graph can answer not just what is relevant to this query text, but what else, right, is connected to this topic that's necessary for me to include in this query, right? You're able to traverse a knowledge graph to see what else is related to this thing. Very, very, very helpful for building out context. All right, so let's get into it. So I have a hands-on demo, and again, this was super fast, but I wanted folks to be able to see. And normally this demo is, this workshop is usually around 3 hours long. So we're going to try and pack as much. We're not going to get very far, but we're going to try and pack as much as we can within this demo. And what's great about Graph Academy is that it provides literally all the information that you need. You don't need me to walk you through this. You can go onto Graph Academy and to the workshop that we're about to do, and you can do this all on your own, right? So as soon as this workshop ends, then you'll be able to finish out the workshop and finish out building out your agent. But first of all, what you'll need in order to get started is all of these links. So we have, and I think that my colleague had pushed this information to you all, but you'll need this dev. So you'll need to go to dev.neo4j.com/workshop/GenAI-notes, and that is going to bring up this document right here. I see a few of you are already in here. So this document here will have our a link to this document as well. You'll need to sign up for Graph Academy. Hopefully you were able to do that ahead of time because it takes a little bit of time to get set up with Graph Academy. And in Graph Academy, that's where we're going to be doing all of this hands-on work. So you'll also see that this is the workshop that we're going to get into. I have that here as well. I was already getting started with you all just because of the GitHub code spaces thing. So I wanted to make sure that we can run this all locally. But you'll see that. And then, yes, everyone, you see in OpenAI API key, right? Yes, that is for you to use during this workshop. Okay, super exciting. Don't worry, we're going to turn this off as soon as this workshop's done, unfortunately. But we wanted to make sure that this, paying and having an OpenAI API key would not be a barrier to you actually enjoying and working with this workshop. So we have that API key for you. And then if you just want to access a Neo4j database directly, we have instructions on how to do that as well. But this is the document that you'll want to get started with. We have the OpenAI API key there. And what we're going to do, since hopefully everyone has already signed up for Graph Academy, we're going to go into the Neo4j and generative AI workshop here. So I'm just going to click this link and we're going to open up this course. So like I had mentioned, this course is normally a 3-hour course. Actually, let me reset myself. It says that I've already done 16% of the progress, and I actually did the whole thing many times. But I just want to make sure again that we were all good for this one. So, okay, so let's get started. All right. A couple of things I'm just going to skip over just for time's sake because, we don't have a lot of time at all. But let's dive in. So we have continued course. We're starting at the top, generative AI. So I'm going to pretty much skip a lot of this. What is generative AI conversation? Because I think many of us have already been in the space, and I don't want to I want to get into what we're going to be doing today. So we're going to skip over a little bit of this work. Press, ready, set, let's go. It's going to give you an overview of how AI works, how generative AI works, what large language models are for those who are new to the concepts, right? What prompts are if you haven't built out an agent before, how you determine your answers, hallucinations within artificial intelligence, accuracy piece evaluations as well. How do you evaluate whether your agent had actually did what it was supposed to do? And then what we had mentioned about hallucinations. So we're just going to skip all over this for time's sake and get to what I like to call the meat and potatoes of things. All right. So a quick overview for those who don't know about GraphRag. GraphRag, the only difference, if you've already heard about RAG, GraphRag, the only difference is that for GraphRag, the retrieval path in RAG, so retrieval-augmented generation, the retrieval path involves a knowledge graph. So I'm actually going to present it, do this presenter view, but the retrieval path includes a knowledge graph. So that's the only difference that you need to know about how GraphRag works. We have an architecture as well, where you can understand how to do information retrieval, how to get the response. But again, I want to get us building. So if you, after this talk, if you want to go back and actually do a lot of the background information, then please do, and it's all accessible here. So I talk about the RAG process, grounding, retrievers, which we're hopefully going to have time to do today, and then different data sources as well. So GraphRag, again, is where the retrieval path in RAG involves a knowledge graph. Perfect. Lots of different benefits to GraphRag as well. We can learn about full text search, Text-to-Cypher. Cypher is the Neo4j query language. And again, it's a lot of context right now, and I'm skipping over a lot, but I want to make sure that we can build. So let's close that out. We did most of this, so perfect. Great. Now, I already went over this a little bit, but what is a knowledge graph? A knowledge graph is a representation of data and how it's related. So we see here that we have Neo4j as a company, and then we have, for example, this is a node, and then we have these relationships connected to another node. So Emil is our founder, still is our founder, founder and CEO. He's the founder of Neo4j. We can see this directionality happening, and Emil works at Neo4j. So we see all this directionality. This is just a simple representation of how data is shown within a knowledge graph. And we already went through that a little bit. Cool. Let's dive in. Great. All right. So now we are going to be working today with the GraphRag for Python package. So this is where we're going to get started. So we have a repository here. It's a GitHub repository. It's already been created for this course. And it contains all the starter code that we're looking for. So we can either use GitHub Codespaces, but I think it's actually down right now. So normally we would do this all within an isolated environment, GitHub Codespaces, but it's actually not working. So what we're going to do is we're going to run this all locally on our machine. So you will already have or already need to have Python installed. If you don't already, I'm happy to provide resources on how to get that done, but we'll do that after this entire talk. But if you do have Python already installed, then let's continue. So we'll want to, of course, set up a virtual environment as well that we'll be working in, because you don't want to just install Python or install pip everywhere, because it'll mess up your other Python projects if you've already developed in Python. But initially, what I want you all to do is to clone this repository here. So github.com/neo4j-graphacademy/workshop.genai. And you can see the actual workshop and all the information. You can either press copy the URL here or just straight from here. And I already have a VS Code IDE up where I have I'm logged into a virtual environment, and I have already run the clone. So I already have the project up. So you're going to just run that clone, that git clone within a terminal, and it will install the entire project. You're going to need to then run pip install -r requirements.txt. You can just copy this so that you can port that into your terminal. But don't worry, you do not need a Neo4j database for this. This is all going to be working within a sandboxed instance. And again, I think my colleague had mentioned there's going to be questions. I'm going to save those questions to after, just to make sure. But I'll take a quick peek. Hello and welcome, everyone. Welcome from Texas. Welcome from South Africa. Okay, great. So now let's actually get started. So what I want you all to do is to copy this. So this is our environment variables. We are going. You already have when you've cloned down this repository, you're already going to have a .env.example. So this is just an example .env. What you're going to do is create another. Oh, I think I'm not sure if my screen just stopped sharing. So let me make sure it still is. Awesome, we're back. Great. So perfect. So I've created a .env file. We've replaced the OpenAI API key with the one that was in that. Yeah, absolutely. Let me bump this text size for everyone. Thank you for the ping. Bump this text size for everyone. We've included the OpenAI API key, and we're going to keep everything else that's the same from Graph Academy. Okay. Awesome. So let's keep those all the same, and then we're going to add the OpenAI API key, and then we're going to test our environment. So I had already done this. What I need to do is you run Python 3 within the folder, Python 3 test_environment.py, and then you should get an OK if your environment's actually correctly set up. And once we've done that, then we can continue. Perfect. So let's go. So I love that it's okay. We're flexible, everyone. My screen share keeps ending, but that's okay. We're flexible. All right. So now let's get into actually building out this. So again, once we're constructing knowledge graphs, we typically are following these steps, right? We're gathering data, chunking data, and then vectorizing that data. And then passing that data to an LLM. Let's try and figure out why this keeps erroring out. But it's okay. Even if my screen doesn't share, keep listening to me. I'm following exactly what's in the Graph Academy course. Okay, so we can know how to vectorize our data, chunk our data, extracting nodes and relationships, and then generating a graph from that. So today, the source information that we're going to be taking will be from the Neo4j Wikipedia page, and it's going to gather the text from that page, split that text all into different chunks, then generate embeddings based on those chunks, and then extracting entities from that, entities and relationships from using the LLM, and then we're going to parse all of that information as well. So eventually, we will generate what the graph looks like. So let's do all of that. Okay, so now we're going to actually open up workshop.genai extract schema. So we're going to go over here. We're going to go to workshop.genai. Then we're going to go to the extract schema file. And here, I'll move this out the way. Perfect. And I'll move this out the way as well, just so that we can stay on the code. Awesome. So we'll see a full schema from text extractor here. So this code is going to use this, let's see, the schema extractor, right, and schema from text extractor class to extract the schema from a given text input. So this extractor here, of course, we can see we have OpenAI LLM. We're going to use ChatGPT 4, which also is going to be deprecated, I think, within the next couple weeks. So we're going to this entire demo is going to be changed over to the newer models. Just keep that in mind. But the whole point of this is that given the text here on line 17, Neo4j is a graph database management system developed by Neo4j Incorporated. It's a simplified version of the extracted schema would look like having some node types, relationship types, and then patterns in general. So let's continue. So yes, we'll have this extracted schema. We're going to continue. And then there's a pipeline for how you would then create your knowledge graph. So next, after we've analyzed this, we're going to go to knowledgegraphbuilder.py. And we can see here that we're starting off, we're doing all of our imports, but then we have this graph database driver here. So let's review what's happening. So it's going to load a single PDF file, right? And we'll go over here. It's going to load a single PDF file. We have this PDF file at the bottom. But initially, we're going to create a connection to the graph database. And we're going to instantiate our LLM model as well. And then after that, we're going to create our embedding model, which we see on line 26. And then we're going to set up this simple KG pipeline here. So KG is just knowledge graph pipeline, where we have the LLM, the driver, the Neo4j database, and then the embedder. And then from PDF is true. And that is this PDF that we see here on line 38. So we're going to run the pipeline to create the graph from a single PDF. So let's try and run this. And we're looking for Python 3, and this file is called kg underscore builder.py. Oh, did I spell that wrong? No such file. Oh, workshop.gen. Okay, let's do Python 3. Then we need workshop.genai/awesome. Okay, so we're going to run the program. It'll happen eventually. It's going to take its sweet time. Workshop.genai. Did I spell everything right? kg underscore builder.py. Yep. All right, but once we run the program, the pipeline is going to process that PDF document and then create a graph within Neo4j. Cool. Nice. Okay, so we see the resolver, a number of nodes to resolve, 6, and then number of created nodes, 0. Okay, so we have, I wonder why it only created 0. Oh, haha. I think I might have needed to run the extract schema first. So let's do this one more time. Python 3. We're actually going to extract the schema first. Schema.py. Of course, you have to get your files, file names correct. Workshop.genai. And this always happens with local development, everyone. If we would have been in our nice system, everything would have worked out. Okay. All right, perfect. So yeah, so apologies. You have to run the extract schema first, which is going to get our schema. We can see all of these different types, the different property names. And then after that, then we would run the knowledge graph builder py, and we'll see how many actual nodes and relationships came out of running that. So let's see. So this is going to take a little bit, but at the end of the day, we should see the resolver, the number of nodes to resolve, and the number of created nodes. And then after that point, again, this is going to run for a little while. We should be able to then explore our knowledge graph. And we could have done that much more easily. Sweet. Okay. So the resolver, still 0 for a number of created nodes. That's perfectly fine. We're going to debug this later because we don't have a lot of time. But that's okay. Number of nodes to resolve. But let's keep going within the space. So if we jump back to Graph Academy, actually, then we can see, jumping back to Graph Academy, and everyone, I'm in section Knowledge Graph Construction. But we can run this Cypher query here. So you can run this Cypher query, and it is going to, we have a match. We're going to match documents from specific documents based on the chunks, and then return the path and the text. So once we run this Cypher query, we can actually see a lot of that information that we had from the Wikipedia article, right? What is generative AI specifically, and then all of this information that we can see from the chunks. So we have a default chunk size, and then we can continue, right? The extracted entities and relationships between them can be found using a variable path query. We can run that, and now you can see this knowledge graph start to be generated, right? So this is all about chunks from the knowledge graph builder that we had just run. And we can see, for example, within this model, I think it's this one right here. What is generative AI, tasks from LLM, AI models, detailed information as well. So let's continue. And what I want to do. Okay, so let's continue. So now we're just going to delete this existing graph so that we have nothing here. And then we can, let's keep going. So text splitter chunk size. So to modify the chunk size, you'll need to create a fixed size splitter object and then pass it to the knowledge graph pipeline. We would then go in and modify the workshop.genai knowledge graph builder.py. So we have our knowledge graph builder.py here. Knowledge graph builder.py. Perfect. We're going to modify this. Perfect. So we have, so we're going to modify the file to import fixed size splitter class. So the fixed size splitter class. So you can copy it directly from the Graph Academy, and we can put it, if we're going to import it, I want to import, I can put it here. Actually, should I put it here? We got it from there. Fixed size splitter. Great. Okay. That should be okay. Text splitter. Yeah, that should be all right. Beautiful. And then we'll also, and make sure to save if you don't have auto save on here. And we'll also edit this simple KG pipeline class. Perfect here. And we'll add the text splitter at the end. So we'll add this text splitter at the end of from PDF. So text splitter underscore text splitter equals text splitter. Okay. Then after that, we will then run this locally. What happened to my terminal? I don't want a new terminal. I want my terminal. Okay, there we go. Great. All right, I don't need the new one. Cool. So now we can run this again. And this is the knowledge graph builder. Yep. We'll run it again. And as that is going, we could jump back over to Graph Academy. And we can actually view the documents and the associated chunks using the following Cypher query. So let's see if that is finished. Yes. Okay, it is finished. And we could run this. Great. So we can view the documents and the chunks using this Cypher query here. There's a lot of syntax here that you might be like, what is Cypher? How does it work? It's hard to go from 0 to 100 within pretty much a 40 to 45 minute lesson that we have here today. I'm not going to dive into the syntax of Cypher for you all. However, if you did want to learn more about Cypher and how to build out these queries, we can go to graphacademy.com and learn more about how to work with Cypher. And Cypher, again, is our query language that we use to talk to graphs, really. So we'll view the entities then after using the following Cypher query. We're going to run this Cypher query here. All right, perfect. Now we see all of these different entities, chunks, etc. So We can experiment with different chunk sizes, as we can see here within Cypher. You can edit all of this information, right, to experiment. So we have chunk, which is going to be to the third degree with entities, and then match all of those chunks. I'm not going to dive more into those, but this is just, I'm going to give you all a primer into all of the things that you can do within Graph, and then building out your graph. So again, this is about a 3-hour workshop that we would normally do, but we're trying to do all within this tiny amount of time. But if we jump to the next section, then we can add the schema to the pipeline. We would open up the Knowledge Graph Builder schema if you're following along. Perfect. So we have the Knowledge Graph Builder schema here, and we're going to review what's happening within this space. So I'll move this all the way over here. You can define specific nodes and edges, nodes and relationship types. We'll go down, we'll scroll down, see, so we have these different node types here. And then we see that we're going to add that node type to our schema and then run it, right? Terminal. I don't want a completely new terminal, but that's fine. Yeah, let's go back to the old one. Beautiful. All right, so this is Knowledge Graph builder underscore schema.py. I'm going to run that. And once that runs, there's lots of different ways to, we're just editing the schema, right? We're recreating a knowledge graph based on all of this information. Love it, love it, love it. So eventually that will work. Great. Yeah, oh yeah, there we go. Okay, so now if we were to go back into Graph Academy, we can view what's happening here, right? So we saw that we just generated a number of different relationship types, a number of different nodes, nodes and descriptions. And now we're going to recreate this entire thing. So we're just going to delete what we had previously. We're going to run this now, view the entities and the chunks. And had no data, of course, right? So run the program. Oh, yeah, because we just deleted it. So run the program. And then once you run it, then it will show all the different chunks. We can do all the relationships as well, and then see what the patterns actually look like within the space. So I'm going to skip ahead a little bit as well. Again, this is just a primer for you all, but I want to skip ahead so that we can get into some more work. So we have structured data happening, lots of different structured data, and we're going to skip down. And I want to get into retrieval and agents, right? Retrieval and agent work. So let's jump down to let's start off with what is an agent. Most people know an agent is a system that combines your LLM with the ability to take actions in the real world. And then we have different components, agents, tools, decision-making, all the things that I had mentioned with the context engineering. But how they work is that they're retrieving different tasks and planning, and then selecting tools, observing, and then iterating. It's this loop, right? This loop of understanding and learning. So let's create the agent. Perfect. So we'll be updating a LangChain agent. So we're going to open up agent.py. I'm so glad we got to this part, because this is where the fun is. So I'm just going to move this here. All right. So within agent.py here, I want you all to try and figure out, okay, so what's this agent's function, right? What is it actually trying to do, right? What do we think this response to the specific query is going to be? So we have a query that we're going to run within the application, summarize the schema of a graph database, right? And then how would we extend this agent even after, right? So in general, what this code is going to do is we're going to instantiate a Neo4j instance specifically, but first we're going to instantiate a chat model for OpenAI, and then we're going to connect to the Neo4j database and then define the get graph database schema, right? So we have this get graph database schema. And then after that, we will then create the reasoning and acting agent using models and different tools. So perfect, models and tools. And then once we run the agent, we're going to pass that query in and then stream out a response. So let's try to run this agent right now. Okay, so we need 113, and we're looking for workshop-genai/agent.py. Okay, what's workshop.genai? Oh, of course. Okay, agent.py. Okay, cool. All right. So we can see lots of different things happening, right? We have our knowledge graph builder happening. We're seeing some constraints. Let's go and scroll all the way up to the top. And so this is showing us different properties, different relationships that are happening within, and of course, like it's hard to visualize because it's all of this text within a terminal type of time to represent what graphs and nodes and edges look like. But this is the response from our agent. So we're going to see within here a message between the human and the AI and tool all together. And then let's make sure first we're going to copy, run the application. So we see for step in agent-stream, we have a message, and then that message is going to have role, user, and content, and then the query that we had just put. And then it's going to stream out those values and then step across those messages, sorry. And then it says pretty print, but it didn't pretty print here because this is not pretty. But it should have pretty printed. And then we can experiment with this query as well. So let's move on as well. So before we finish everything, because this is not necessarily finished, but we're just trying to build out our agents. So we'll go back to the Neo4j Graph Academy course. And so we'll see that we can modify our agent to then create a vector cipher retriever that uses a chunk for the vector index, and then defining new tools, and then adding new tools as well. So I don't think we're going to do that right now, but if we were to have time to do it, we would update our agent with a specific embedder here using text embedding ADA-002. And then we would create a retrieval dash query, right? That the retrieval will use to add the additional context. So we see that this is a retrieval query which is going to retrieve all of the different chunks, all of the different nodes, and all the different entities from our results. And then return them as items in values, and then we see here, and then we're going to format it as associated entities. So these are when I said entities, we have entities and relationships. Entities are the nodes, right? Just representation of all of that data. And after that, we create a vector cipher retriever using a chunk embedding index with a Neo4j driver. This is just a way to interact with your Neo4j graph database, and then the embedder itself. So you can define the tool function to search out the lesson content for that specific retriever, and then update the tools and modify the query. And we have the completed code there as well. Okay, so lastly, we would be able to query the database and then officially create the entire agent as well. So maybe we have a little bit of time just to go through what these steps would do. So querying the entire database, we'd use a tool called Text-to-Cypher retriever to retrieve and to convert those user queries into cipher statements. So it's like Text-to-Cypher takes a natural language query and turns that or transitions that into something that a graph can understand. So oftentimes you'll see, for example, we have a knowledge graph, LLM knowledge graph builder tool, which takes in natural language and puts out the answers to your questions based on based on traversing a knowledge graph. So with this tool, you can, it's pretty much the same thing, right? So it's actually taking that text, converting it to Cypher, and then retrieving the information that's necessary for your agent to know. So you use that database query tool in order to do that work, and then we'd modify our agent based on that actual retriever. So we see where we would import the retriever, have an example, find a node with the name, whatever name, and then query, and then a sample query as well. So we provide the sample query so that you don't have to know how to write Cypher. But this would be the translation between what a human readable query would be like, and then the actual query, Cypher query, that would be necessary in order to return the answer for the information that the user had asked. And we would build out the retriever from that place. So then we define a tool function to query the database using that specific retriever. We'd have the tool, which is query database, and then we've defined what that tool actually is. It's a catch-all. Specifically here, it's a catch-all tool to get answers for specific questions about lesson content. And then we would return the result from there. And you can update the whatever kind of tools that you want to use, get schema, search lessons, or query the database. You can include whatever tools that you're looking for, and then modify the query as well. And then we'd run the agent and see the output. And then the last piece of the puzzle here, because we have a little bit of time, and this is an optional challenge, right? So for this challenge, you're going to apply what you've learned with all of this. So when you go through the entire course yourself, you'd apply what you learned from this and try to create an agent that creates a custom set of tools. So you can do the lesson knowledge graph, which is this entire like lesson. Use your own knowledge graph as well. You can augment to use your own knowledge graph still within Neo4j Sandbox database, so you don't have to worry about any hosting problems or anything like that with your data, but from either the previous challenge or your own information, and then creating a agent using the example code from this workshop to gather that information and gather that important context, defining that set of tools, whatever set of tools that you want to use, and then testing the agent with different user queries to see how it actually performs, right? To see if it actually is using these tools that you provided in order to get the answers that you're looking for. Okay. And okay, perfect. So again, this is a very short, very short primer on how to build out agents. This is normally a 3-hour course. So we had to skip a lot of like foundational information. If you're brand new to knowledge graphs, you might be like, oh, this is a lot. This is super confusing right now. But what I want you to do is to actually go through this course, because it's actually very detailed on taking you from 0 to 100, right? On building what is GraphRag, what is knowledge graphs, context graphs as well. I didn't get into the crux of context graphs, but I do have a demo that I can show you. But really what context graphs does is that it takes all the information from your agents, takes all the context, and it actually shows you the why behind the decisions that your agent has made. So instead of just building out an agent and it, making whatever decisions that it makes, using a context graph would allow your agent to understand, why did I decide that, right? So for example, if you're in a financial industries area, then and you're building an agent that is asking, oh, should we provide a credit line increase to Jessica, right? For example. Your agent's going to then either say yes or no, we should provide that credit line increase, but it's actually very important to understand why we should do so. So context graphs elucidates what we call decision traces, which is the history of how an agent got to its decision that it makes today, right? So it takes in all the information, all the added context to allow your agents to be able to answer why, right? Why did you decide this decision? and what are some next steps that we would take based on that. So that's a whole different demo. You have to kind of like know a lot of this background information in order to be able to get to that point. So it can be a little bit complex, but I think that it's necessary for those of you who are on the call in order to understand how you can build out agents that use context as well. And what I want to do is I'll even show you all context graph. For Jay, we have a blog post on how to build out context graphs done by my colleague William Lyon, and I'll post this in the resources chat as well for you all so that you can have it. Yeah, of course, no problem. I'll post it to my colleague so that he can. Beautiful. And so this both is a blog post, but it also includes the live demo of this context graph piece. So I do want to save some time for questions, but you can see for this, if we were to, if we were to approve a credit limit increase for this person named Jessica, why should we or why shouldn't we? And we see all of the decisions of why we shouldn't, in this case, actually approve that for Jessica. And that's, in this case, is because she actually has a lot of fraud that has happened on her account, where someone was trying to get access to her data, not her data, her money, really. And they were trying to ask, for this credit line increase so that they can take more money out of her account. And we wouldn't have known that unless we had been able to do this decision trace and understand that actually there was a big fraud piece that happened 3 months ago. We should not approve this credit line increase to protect Jessica. So this isn't Jessica. This is a fraudulent player right now. So excellent demo, excellent resource to learn more about how context graphs make your agents more successful, more trustworthy, and more auditable as well. So I'd highly recommend that you check out the context graphs demo here, which shows you everything live. So yes, I'll let this run, and then if we have any questions, happy to take them. And hello from Texas. It's a super cool demo. Yeah, I appreciate y'all so much. Oh, thank you. Perfect. But yeah, you can see all the decisions that are made. I'm not going to dive into this demo because it's a completely separate one, but if you have any questions, either based on this, and then we see the recommendation to reject. So yeah.
Perfect. Cool. Thank you so much, Nyah. That was incredible. And yeah, hopefully everyone managed to do some part of that. Again, if not, don't worry. You can catch up with the recording. Make sure you register for the session so that we can send you the recording as well. So we've got a couple of questions from the audience. If you have any questions, everyone, please do ask us them now, and we'll get to them very shortly. In the meantime, though, I've got a couple of my own questions. So is it possible to provide too much context to an agent?
Good question. Okay, so yes, and there's reasons for that. So I would say that there's ways to provide too much context to an agent because it would be based on how you're providing that context, right? So like I had mentioned in the slides, like there's different ways that you can do context engineering in general, right? Either by structuring and ordering the context within the prompt that you're providing to your agent, or using knowledge graph augmented context. But there's lots of different ways that you can provide context. And when you do, if you provide quote unquote too much context or the wrong context, you can result in what's called like, so for example, if we're doing normal RAG, right? Normal RAG, there's ways to provide context within the normal RAG process. There's this thing called context poisoning. which happens when you are trying to base your agent on which normally works, normal vector-based RAG. However, sometimes when you're using normal vector-based RAG, your system is going to provide off target information. So you're actually looking for this information right here, but it's providing off target information. It's just slightly adjacent to the thing that you need, but it's actually not what you need. And so what happens there is this concept called context poisoning, where you are getting, where you're providing context, but it's actually giving you back the wrong thing. So yes, I would say that there's ways that you can provide too much context. I even seen people when they're developing agents and when they're just using agents, they just try to like overload the context window and just provide as much information, feed it the world, right? Like the agent will be fine. It's going to figure itself out, but actually no. This is why my entire definition of doing proper context engineering is providing the right information and the right structure at the right time. Okay, that at the right time is also key. So I think that that's really important when we're thinking about building out context.
Got it. We've got a few questions from the audience. First one is from someone on LinkedIn whose name I'm not allowed to show.
Of course.
It's why is ordering associated with memory?
Why is ordering associated with memory? So that's a good question. I would say that structuring and ordering context, one could think of them as completely separate, but I would say that they're a part of the same field. And that's because, like, if you're ordering your context within, and let me see if I can bring it up. Thank you. Oh, you're the best. Thank you. Yeah, perfect. So when you're ordering out your context, right, you have to, and it's a part of this, like thinking about memory management piece. They're not the same. They're not the same concepts, but they work with each other, right? So the structure and the order of your context is going to matter because it's your agent is then still thinking about like, okay, what is the priority here? And especially when you're thinking about memory as well, it's very similar to memory management. We're thinking about like, what can I forget? So I'd say that they're not the entire same concept, but they are related to each other.
Got it. We had a question from Glenn on YouTube. He said, any thoughts on the RIG framework in Rust for building out AI agents or vector stores?
I'm not familiar with the RIG framework. So so usually I'm a JavaScript and Python developer, so I haven't worked in Rust. But I'm gonna do some research on the RIG framework in Rust and then get back to you on that. You're on LinkedIn, so I think that I can.
Yes.
I can
yeah. Recommendation there would be follow Nyah on LinkedIn and then badger her for an update very soon. And then the final question that we've got from the audience is from Dan. And Dan says, do you mean to save the reasoning output as a node in your graph? So this was a little bit later on.
Oh, do you mean to save the reasoning output as a node? You can save it. There's also, so yeah, I think that actually be an intuitive way to display and show that information is by showing it as a particular node on your graph, so that it's actually stored within your graph and you're able to query that information or rerun that information later and actually have that output for later query, so it doesn't have to do a big traversal yet again. So yeah, that's definitely a way to do it.
Cool. And then I'll sneak in one final question from Omar. So Omar asks, what does context at the right time mean?
Good question. Good question. What does context at the right time mean? So when you're building out your agent, again, looking at all these different ways that you are providing context, context at the right time is focused on when you, and thank you for showing the slides, but it's focused on like, when is your, let me think of a good answer to this. I'd say it's like when you're developing out your agent, where are you providing that I'll say like, where are you providing that context? and when are you providing it as well? So if you're building your agent and you're thinking about like providing your context either in the prompt window or as you're building out your knowledge graph, for example, understanding when to include all this context so that you're not just overloading your context, I think is something that's important to focus on. But I'm happy to have more conversation about it, either offline.
Perfect. Cool. So I think that's all the questions that we've got from the audience. So, actually, we've had Dan follow up regarding. So he says, regarding my earlier question, context was about recording the agent's decision for auditing. Might you capture the model's output verbatim, including the reasoning?
The context was about recording the agent's decision for auditing. Might you capture the model's output verbatim, including reasoning? Yes, within the not within Neo4j, within the knowledge graph, yes. But yeah, happy to get into it.
Cool. Brilliant. So that's it for today. However, before we shut up shop today, we do have a few more things coming up. If you are interested, we have our AI-powered Python series that's coming up very soon. If you head over to DataCamp, we have a big banner on the top of the website allowing you to sign up for that. So yeah, if you're a relative Python beginner, but you want to infuse your journey with AI and learn it better and do it probably a little bit easier, then head over there. And we also on April 1st have our flagship virtual conference Radar. So please do check that out. You can just search for DataCamp Radar and you'll find the link for that. Make sure you sign up for those. That one's on April 1st. And then AI-powered Python is a similar time as well. So make sure you check those out. And obviously, please do also check out datacamp.com/webinars where you'll find this session as well as all of our future sessions as well. So yeah, Nyah, thank you so much for taking us through that today. I certainly learned a lot and hopefully everyone else did today. We'll be back again on Wednesday where we're talking through dashboards. So check out that session, and we're also going to be looking at healthcare dashboards soon as well. So please do check out datacamp.com/webinars. So yeah, thank you to everyone who tuned in. Nyah, thank you so much for taking us through things today. And yeah, hopefully we'll see you again soon.